Yes, welcome to another presentation on electromagnetic wave equation for magnetic fields. Electromagnetic wave equation for magnetic fields. In the last presentation, if we recall, there we have seen the same electromagnetic wave equation for electric field, right? As I already explained you in previous presentation, so EM wave is nothing but it is the combination of electric field, right? It is the combination of electric field and it is denoted by capital E, where capital E is the electric field strength, right? Electric field strength. Similarly, it is magnetic field, right? Magnetic field. So, this is denoted by capital H. Therefore, it is the EM wave is nothing but electromagnetic, means this is electro, this is magnetic. Therefore, E plus H, right? The combination of these two fields gives rise your electromagnetic wave. Is it not? So, in our previous presentation, we have seen the wave equation for electric field. There we have seen this is del square into E is equal to epsilon naught times mu naught into E double dot. This is what we have seen in previous presentation. Del square E is equal to epsilon naught into mu naught into E power double dot. Clear? It is free space permittivity and free space permeability. This is what the expression for electric field. This is called the wave equation for electric field. So, this del square E is equal to this particular is called as, this equation is called as the wave equation, electromagnetic wave equation for electric field. In today's presentation, let us see the same expression for magnetic field. What is the wave equation for magnetic field, right? So, that is something like this only, right? So, the magnetic field equation is also exactly similar to our electric field. So, that can be written as, that is del square H is equal to epsilon naught into mu naught into H over double dot. H over double dot. This is what the wave equation. Okay, this is what the wave equation or electromagnetic wave equation for magnetic field. For magnetic field. Clear? Very good. So, this we have to prove. Means that del square H is equal to this much. This is what we have to prove in this presentation, right? For that, what we need to do, let us recall the Maxwell's equation from Ampere's law, right? The Maxwell's equation from Ampere's law can be given as, it is del square in cross H, means del cross H is equal to, it is JC plus JD. Clear? From Maxwell's equation. Why? Because we need to prove that del square H. Is it not? We have to prove that del square H. Therefore, you have to take the Ampere's law equation. This is the Maxwell's equation, one of the Maxwell's equation, which is nothing but it is a Ampere's law, right? So, from the Ampere's law, del cross H is equal to JC plus JD. Clear? And what is JC? JC is nothing but further, it is called as sigma times E. Plus, what is J suffix D? Displacement current density. J suffix C is the conduction current density. So, your JC is equal to sigma times E, right? JD is equal to, it is dou D by dou T. Displacement current density, del cross H is equal to, right? Therefore, your JC is equal to sigma E, JD is equal to dou D by dou T. Is it not? Now we know that for free space. Why? Because these expressions we are deriving for free space, right? Therefore, for free space, what is the condition? For free space, so the sigma, the conductivity becomes 0 because the free space is a non-conducting medium, right? It is a non-conducting medium. So, it means that your sigma becomes 0. Therefore, sigma value 0. Substitute this sigma is equal to 0 in this expression. You may call it as 2, nothing wrong in that. Substitute sigma is equal to 0 in equation number 2. Then obviously your del cross H becomes what? It is 0 plus means simply dou d by dou t. So this is the expression. This is the expression, the third expression. Clear? This is the Ampere's law. Ampere's law for free space. Ampere's law for free space condition. Now, for this, what we need to do is that apply the curl operation on both sides. By applying or taking, what is this? Taking curl operation. Taking curl operation on both sides. On both sides. What you will get? What you will get? So by taking the curl operation, what is the curl operation? Curl operation is nothing but del cross of something. This is called curl operation, del cross of something. That means that, so I will write the subsequent expression here. So this is nothing but, so for this del cross H, if you apply the del cross, I mean curl operation, del cross of del cross H, del cross of del cross H. Already del cross H is there. For this we have to apply curl operation. It is del cross. So del cross of H is equal to, it is del cross of dou d by dou t. Dou d by dou t. This is what the curl operation. This is what the taking the curl operation is nothing but del cross you have to write on both sides. Del cross. Is it not? Therefore, so further this can be extended as, so from the vector identity, as we have seen in our previous presentation, from the vector identity, this particular can be the left side part, del cross of del cross H can be given as del of del dot H. Del of del dot H minus it is del square H. You can write like this. This can be simplified as, this particular can be simplified as del of del dot H minus del square H is equal to, right? So this is what the equivalent for this from your vector identity. Now this can be written as, so it is del cross, what is dou d by dou t? Dou d by dou t is nothing but, here you need to remember d is equal to epsilon e. That you substitute here, means that in dou d by dou t, in place of d, substitute epsilon times c. Clear? So this is equal to, epsilon is the constant. Clear? Epsilon is the constant, or otherwise you can write like this also. Del cross, take epsilon is outside, and then dou t by e is nothing but you can write as e dot. You can write like this. Why? Because the first derivative of e is nothing but e dot. E dot is nothing but, if you put the dot here, this indicates the first derivative. Therefore, this furtherly this can be written as epsilon is the constant. Therefore, you take epsilon outside. Then if you take this delta, I mean del cross e, you can write the same del cross e. Right? Therefore, this can be written as, this is a simplification actually. So what I did is, in place of d, simply I have substituted epsilon e. Epsilon is a constant, I have taken it outside, and so here dou by dou t of e is nothing but e dot, and just you take epsilon outside and del cross e dot, that you can put in bracket. So this is what means that, therefore del of del dot H minus del square H is equal to this. This is the expression now. Del of del dot H minus del square H is equal to this. This is the equation. In this equation, again from the definition of your mu, what is from the definition of B is equal to mu H. This is one of the constituent formula, right? This is one of the identity otherwise. So B is equal to mu H. Is it not? B is equal to mu H. Therefore, if you if you write that del operation, if you take the del operation del dot B, then obviously this is nothing but mu into del dot H. Is it not? Or otherwise you can write in a very simple manner that from the fourth Maxwell's equation del dot B is equal to 0, no? What is the fourth Maxwell's equation? Del dot B equal to 0 means the Gauss law for the magnetic field. Is it not? Del dot B equal to 0. This is from the fourth Maxwell's equation. Now in place of B, substitute mu H. Therefore, del of, in place of B, substitute mu H equal to 0 obviously. Right? Then take mu as outside. Then obviously it is del dot H. What is this value? Therefore, from this you can write del dot H equal to 0. Therefore, from this definition, this particular part becomes 0. Clear? This particular part becomes 0. Therefore, what you will get on the left side, this becomes 0 because from the fourth Maxwell's equation, remember, from the fourth Maxwell's equation, you can get delta H equal to 0. Therefore, what you will get in the next expression is that, what you will get, I will write here, right? So, you will get like this. So this part becomes 0, therefore I can write the next subsequent expression as like this, delta square H only minus delta square H, because this becomes 0 is equal to, then it is epsilon of, what is this, del cross E dot, is it not? Del cross E dot. Now again, what we know from del cross E, what is del cross E? We know that del cross E is equal to minus dou B by dou T. This is from the one of the Maxwell's equation. This is Faraday's law. This is called Faraday's law. So from the Faraday's law, del cross E is equal to minus dou B by dou T. Nothing but what? It is minus. You can write B dot, no? Is it not? Del cross is equal to minus dou B by dou T, or the first derivative of magnetic flux density. Therefore, this can be written as minus B dot. Therefore, del cross E is equal to B dot. Now, what exactly is there? Del cross of E dot means, del cross of E dot means you have to take another derivative. This means that dou by dou T of minus dou B by dou T. So, already del cross is equal to this much. Now here what exactly required? Del cross of E dot means, for this we have to take first derivative, means another derivative, dou by dou T of dou B by dou T. Nothing but what actually? It is nothing but minus dou square B by dou T square. Clear? Take minus as outside, dou by dou T of dou B by dou T, nothing but dou square B by dou T into dou T square. This is nothing but minus B double dot. This is nothing but B double dot because second derivative. Therefore, is it not? And this further can be written as minus. So, in place of B, what you can write from the constituent identities? B is equal to mu H. Therefore, mu into H. Now, the same double dot can come here also. Because in place B is equal to mu H, I am simplifying. I am substituting. Therefore, mu is the permeability. This is constant. Therefore, it becomes mu of H double dot. Mu H double dot. Therefore, now del cross, so means that what? Del of E dot. Del of E dot is equal to minus mu times H double dot. Substitute this value in this particular expression. Therefore, this expression becomes as what, already epsilon is there outside. Therefore, what is del cross E dot? Del cross E dot is nothing but minus mu of H double dot. Clear? And there is a simple, one more simplification line is there. That is nothing but this implies, take this mu minus outside, it is epsilon mu, right, H double dot. What is this? What is the left side? Minus del square H. Therefore, minus del square H is equal to minus mu epsilon H dot. Therefore, minus L will be cancelled out. Then what you will get, delta square H is equal to epsilon mu H double dot. And as we are, explaining this expression for free space. For free space, remember that epsilon is equal to epsilon naught and mu is equal to mu naught. Remember that for free space, epsilon is equal to epsilon naught, mu is equal to mu naught. Substitute these values again here, then this can be written as epsilon naught mu naught into h double dot. This is the proof. Therefore, you can write finally del square h is equal to epsilon naught mu naught h double dot. This is the wave equation for magnetic field. This is the wave equation for magnetic field. Clear? So, in the previous presentation, we have derived the wave equation, means electromagnetic wave equation for electric field, whereas in this presentation, we have derived the expression for wave equation for magnetic field. Remember, right? So, let us finish off this presentation here and we will see the next subsequent topics in our next coming presentations, right? So, have a good day.